Have you ever wondered how a mobile operator decides how far a 5G tower can reach? It's not a guesswork, it's called a link budget, the backbone of wireless coverage planning used in uplink and downlink. So, link budget is like a financial plan, but instead of money, we are budgeting the signal strength. In simple words, it tells us what is the maximum allowed path loss a signal can tolerate while still maintaining a reliable communication between the device and the base station. Now, let's break it down in downlink scenario where the transmission is happening from the BTS. So we have certain key terms here and the calculations we need to do in different parts. The first calculation we have to do in this case at the transmitter end, where we need to calculate what is the effective isotropic radiated power, which is EIRP. Now it depends upon a couple of factors. What is the transmit power from the radio module? So depending upon the specification of the radio module, we could have a different transmit power from its ports. It could be here, for an example, we are taking 23 dBm. Now, in case of midband, which we are considering here as an example, we would have the different antennas and antenna elements which are used for massive MIMO. Here we are considering we have a massive MIMO with 128 antenna elements. We used a formula 10 into log 128 antenna elements, which gives 21 dBi additional gain. We'll have some antenna gain on the top of it. And we are also using the beamforming in this case, where we are using the same logarithmic formula, which is giving us the 18 dBi additional beamforming gain. We have some connectors, cables, we are considering some loss, and then we are coming down to the EIRP, which is the summation of all these 5 different points. The EIRP in this case we got as 67.13 dBm. This is at the transmitter end. Now it has to pass through the walls and it has to consider the different interference margins while passing over the air interface. Now we are here considering certain margins for fading, such as 4.48. We are considering the penetration margin because we are calculating the coverage to be provided to the consumers indoor in buildings. In that case, it has come out to be a total margin of 30.73 dBm in this case. Now at the receiver end, we have certain thermal noise and some noise power which need to be considered. We have certain gain of the antennas. We have certain antennas on the mobile station or the user devices, and hence we got certain receiver sensitivity here, which comes out to be minus 90.95, and we have an antenna gain of 3 dBm. Now in case of MAPL, we have to subtract the margin and receive sensitivity from the EIRP and then add up the gain at the receiver end. This comes out to be 130.36 in this case. And from there, we will calculate the cell radius. We have a formula which we will simulate in the next slide. But if we keep on changing the frequency, we keep on changing the base station height, in that case, we'll have a different cell radius. So whenever we plan a network, we're always mindful about the antenna height, the frequency band that is being used. And then on the top of that, what kind of radio module we are using, what kind of antenna we are using, and all those things will then collectively give us a value of maximum allowed path loss, which in turn give us the cell radius. So this is the broader picture of the link budget, which we'll understand and simulate step by step in the next slide.